Ever feel like there's a secret agent hiding in a math problem? Well, in two-step equations, the variable you are trying to solve for is like that secret agent disguised with a little extra information. But fear not, detectives. Today, we'll learn the tricks to crack the code and isolate the variable in two-step equations. Calling all algebra adventurers. Ready to unlock the next level of algebra. Today's quest: conquering two-step equations. These equations might look intimidating at first, but fear not. They are like one-step equations with a little extra challenge. Why is this challenge easy to conquer? 2 reasons. First, you are one-step champs. You've already mastered one-step equations, which is a huge head start. Second, your guide to greatness. You've got me by your side to show you the ropes. Our two-step mission: what's the mystery? We'll unveil the secrets of two-step equations and understand how they differ from their one-step counterparts. Balance is key. Learn how to manipulate the equation strategically to isolate the variable, all while keeping things balanced. Remember, math is a journey, building on what you've already mastered. So, if you're an algebra rock star, this will be a piece of cake. Let's get started. A two-step equation is a one-step equation with a constant attached. It can be attached with addition or subtraction. To move it to the other side of the equation, you must use inverse operations. This will make sense once you see a few examples. Here is our first example. The problem is 2 times x added to 8 equals 10. The first step is isolating the variable term. There is an 8 attached to it with addition. Since the opposite of addition is subtraction, we remove it by subtracting 8. If we subtract 8 from the left side of the equation, we must also subtract 8 from the right side. In this problem, that means we must subtract 8 from 10. Once we do this, we will divide both sides by 2. The next slide illustrates this. Here is the work from the previous slide explained. The original problem is in the first box. The second box shows the constant being removed by using inverse operations. In this example, we are subtracting 8 from both sides. The third box now has a one-step equation. These are easy because we use the inverse operation to get the variable by itself. Since 2x is 2 times x, we know we must use division to get x alone. This is how we got x is equal to 1. In the next slide, we will double-check our work by substituting 1 for x and simplifying. In this slide, we replaced x with 1. 2 times 1 is 2. So, now we have 2 added to 8. When we combine 2 and 8, we get 10. Since 10 is equal to 10, we know x equals 1, and this statement is true. This problem introduces negative numbers into the equation mix. Don't worry. Negative numbers aren't scary monsters hiding in the math world. We'll tackle them together, step by step. Our example of 3 times x subtracted by 9 equals negative 12 is just like the previous problem. We will add to both sides of the equation and then divide by 3. The only thing you need to remember is that the addition sign or positive number moves you to the right on the number line, while a negative sign or subtraction sign indicates moving to the left. If you are at negative 12 on a number and move forward 9 places, you will be at negative 3. Here is the work from the previous slide explained. In the first box is the original equation: 3 times x reduced by 9 is equal to negative 12. In the second box, we remove the negative 9 by adding 9 to both sides of the equation. In the third slide, we divide negative 3 by positive 3. Since a negative divided by a positive is negative, our final answer is negative 1. We will double-check our work on the next slide. To double-check our work, we substitute -1 for x and simplify. 3 times negative 1 is negative 3. Next, we subtract negative 9 from negative 3. If you use a number line, Start at -3 and move to the left or backward 9 units. If you did this, you will be at -12. Remember, subtracting a positive number from a negative number is the same as adding its opposite, a positive number, on the number line. The answer will remain negative. Let me know if you need more of an explanation. Finally, we have -12, which is equal to -12. This means our statement must be true. Now that we have examined two equations, it is time to organize our work. On the practice problems, you will be given a problem that looks like this. The problem will be in a big box. In the box that states step 1, you will remove the constant. In this case, it is a +4 attached to the variable term, which is the term with the letter. In this case, the variable is x. In step 2, you will divide both sides of the equation by the coefficient, the number in front of the variable. In this case, 2. In the answer box, you write your answer. This will be demonstrated on the next slide. In the first box, we will write the inverse operation of subtract 4. In the space below the equation, we will complete the actual work. As you can see, on the left side of the equation, we now have a 2x added to 4, subtracted by 4. On the right side, we have 4 subtracting 4, simplifying to 0. We conclude by writing 2x equals 0, before moving to step 2. Now, we divide both sides by 2. 2 divided by 2 is 1. So, we will write the variable x, because a variable by itself has an understood coefficient of 1. 0 divided by 2 is 0. Therefore, x is equal to 0. We will check it on the next slide by plugging 0 into the equation for x. Here, we are checking our work. We multiply 2 times 0, which is 0. Next, we add 0 and 4 to get 4. Finally, we see 4 is equal to 4. This means our work was correct, and this statement is true. This example has a coefficient, or a multiplier written as a fraction. But don't worry. Fractions are just another way of representing division. Here's the twist: instead of multiplying by the entire coefficient like before, we'll only multiply by the denominator, or the fraction's bottom number. Why the change? Think of the fraction as a way to divide by the numerator, top number. So, multiplying by the denominator is like undoing that division and getting back to the original variable. Ready to test your skills? Pause the video and try solving this example yourself. We'll check the answer together in a moment. Let's compare notes. I started by adding 4 to both sides of the equation. This is why I put add 4 in the step 1 box. When I add 4 to -4, I get 0. So, on the left side, I have 1/2 of x. On the right side, I added 4 to 4 and got 8. Now, I have 1/2 of x is equal to 8. We are ready for step 2. For step 2, I will multiply both sides of the equation by 2. Since 2 times 1/2 is 1, I am left with 1x on the left side of the equation. The 1 is understood, which is why we don't write it. On the right side of the equation, I multiply 8 and 2, which is 16. The final answer is 16. We will check it in the next slide. We are checking our work by replacing x with 16 and simplifying. Since half of 16 is 8, we rewrite the problem as 8 minus 4. On the following line, we subtract 4 from 8. This gives us 4. Finally, we have a true statement of 4, which is equal to 4. So, our work was correct. Good job. We've conquered two-step equations. Remember, the key is keeping the equation balanced while isolating the variable. Here's a quick review of the steps. First, isolate the variable and say goodbye to the constant. To do this, you must identify the constant term, the number added or subtracted to the variable. Then use the opposite operation to remove the constant from the variable side. If the constant is subtracted, add it to both sides. If the constant is added, subtract it from both sides. In step 2, we welcome back our old friend, the one-step equation. This step should feel familiar. Treat it like a one-step equation and solve for the variable. If the coefficient, the number multiplying the variable, is a whole number, divide both sides by that number. If the coefficient is a fraction, multiply both sides by the denominator. You know the fraction's bottom number. Remember, by performing the same operation on both sides of the equation, we maintain the balance and solve for the variable. Are you feeling confident? Great! If you have any questions, don't hesitate to ask.